I'm doing 37.11 now, and this one is talking about muons, I think, some kind of particle. Yeah, muons. And then it says that the time that it travels in its own reference frame is 2.2 times 10 to the negative 6 seconds. And the very first part of this question asks, how far does it travel in its own reference frame? So we say that the distance, which we're trying to find, is equal to the time that it lives, and then that's multiplied by the velocity that it goes. It doesn't tell us the velocity initially, so all it says it goes close to the speed of light, so I just use the speed of light. And then when we calculate that, we get that it turns out to be 0.66 kilometers. And we're putting this in kilometers because there's a bunch of parts of the question that ask about kilometers. Okay, so that's for the first part. For the second part, I think it asks how fast or how long does a particle live as observed by someone on the Earth. And so we have our delta t, which we're trying to solve for the person on the Earth, is equal to the speed of the particle, or I mean the time that it lives in its own reference frame, divided by 1 minus the speed, which we just calculated. Wait, we didn't calculate it. Oh, the speed then it tells us is 0.999 c over c squared. It's part squared. Okay, so then when we go ahead and calculate all of that out, the c squareds will cancel out. We'll have 0.999 squared, 1 minus that. Calculate all of that, and then that's going to give us that it is alive for 4.92 times 10 to the negative 5th seconds as observed to someone on the Earth, which is actually a significant difference from how long it already lives over here. So that's actually pretty interesting. Let's see. So we calculated how long it lives with someone on the Earth, so then we want to see, with respect to the person on the Earth, how far is it going to travel. So we put in its speed, the time that it lives, multiplied by its speed, which is 0.999 times the speed of light. Then we're going to calculate that, and we're going to find that it goes 15 kilometers as observed to someone who's on the Earth. And then this question says that usually the cosmic rays are bombarded the upper atmosphere about 10 kilometers above the Earth's surface. So we wanted to see why do we still experience the muons or something? And it's because right here it's going 15 kilometers and it only really has to go through 10 kilometers. So now that we've gotten that far, we have one last part. In that part, we want to know the length contraction of the muon, and that is equal to, let's see, this is the 10 kilometers of the atmosphere that it usually has to go through. I just made it into meters, and that is multiplied. We're just using the same kind of we're using the length contraction equation. And we know it's going to be right if it's going to be less than this, which it will be, because when we calculate this, we're going to get that the length contraction of the muon is 0.45 kilometers. So it sees itself going through 0.45 kilometers, but in its lifetime, it can travel 0.66 kilometers. That's what we found from the very first part. So then it asks, does it make sense why we still experience muons? And it's yeah, because this is how far it does go. This is how far it can go. So it happens.